Okay, sorry about that. All right, so just a couple of reminders. First thing, make sure you're taking roll every day. I think everyone's been good about that. I very rarely get emails anymore about kids forgetting, so that's good. Good job there. Second, I want to remind you, I don't mind doing any late work for you guys, grading any of the late work, but don't send me an email with it, okay? I don't care. I get hundreds of emails and your emails are too vague and I don't know what to check, and I'll go check something and I still won't have the permissions to see it. So I don't mind grading late stuff, or if you want to improve a grade that you didn't get good and you want to make it better, I have no problem doing that, but do it at the end of class, okay? Every single day I give you time at the end of class to do that. So just make sure you're reminding me and I will do it at the end of class. I'll grade it right in front of you. So that way, if there's any problems, you and I can discuss it right then and there. And if there's a permission problem, we'll get it sorted out and fixed. Okay. So please, no emails on grade stuff. Talk to me during class. Okay. All right, what else we got? So we're moving along with electricity. Probably the most complicated part of the whole lecture was the one we did yesterday. So gets a lot easier from here on out. It's also a lot more practical, and we'll be learning about the things we'll use in the class quite a bit. So we talked about, let me actually pull it up here real quick. I'll share screen first. Okay.
What were those rings called again?
There we go.
Rob, do you copy?
Let me turn that down. So we talked yesterday about metal being one of the good conductors, and we'd mentioned some of the different metals that are better or worse at doing it. And so I looked it up yesterday just to kind of double check.
I do not.
And so it looks like pure silver is the best. Okay, pure silver is the best. And then gold was closely following. But I did want to remind you, oops, let's see here. Sorry, I got a couple people entered the waiting room. Let me just let them in real quick. Okay, he's already here. Okay. But I did want to remind you, it's kind of confusing on what is the best metal for conductors, because there's other things that go into it too. For instance, when we talk pure silver, you're not going to see pure metals very often in electrical work. Okay, it's not very often. It's very hard to get metals to be so pure, and it's very expensive. So typically, even when we talk about other metals, it's not going to be pure. Okay, it's going to be alloyed or mixed with another metal. And one of the problems that we also have too is metal expands and contracts differently, and that's a big part of making wires and electrical components, is the thermal expansion. And so that plays a key role too. So it's not quite as simple as what has the best electrical format when you're looking at the elemental charts and looking at all the properties. Is a very complex equation, and so it's not as easy as just picking the metal that is electrically the best. Okay, a lot goes into this stuff with the cost, the weight of the metals, the way it expands and contracts. That's called its thermal expansion rate. And so there's a lot that goes into this kind of stuff. The alloys, how they're corrosion resistant. So there's a lot of different things that go into that. So it's always kind of a hard question to answer. But anyways, we don't need to worry about that right now. In general, we're going to only be using two metals in the electrical field. We're going to be using copper and aluminum. Hold on, I got a couple chats here. Let me just look here. Okay. Okay. Yesterday. Sure, that would be fine, Angela. Yes, we'll be taking notes today. again, whenever you see this stuff come up, we're gonna be doing notes. Like I said, this is a long lecture. There's a lot to the basic electricity. We're not gonna do it all in a row because I just don't want you to be stuck doing notes for all this time. But it is important to how we learn about electricity to understand all the basics. Okay, so I think yesterday we left off at conductors, right? And we did write down conductors in our notes. That's one of the most important things we're going to be using this year. So conductors are what we do as electricians. We fix conductors, we connect conductors, and that's a big part of what we do. Without conductors, you have no electricity, okay? So conductors are super important, and those are anything that's going to allow the flow of electricity, okay? And what we really look for are things that are good at allowing that flow of electricity. Okay, next thing I wanted you to write in your notes is insulators. An insulator is not capable of supporting the flow of electricity. Now, all of this stuff is relative because the more electricity you force into something, the higher you get the voltage on something, the more likely it is to conduct electricity. But in general, insulators try to resist the flow of electricity, okay? So an insulator is not capable of supporting the flow of electricity, okay? Again, that's partially true. A lot of this stuff is relative because if you put enough electricity through almost anything, it tends to start conducting it. So anyways, an insulator stops the flow of electricity, and some of these good examples are rubber, wood, ceramics, and plastics. And I put a picture up there of the top of telephone poles. You've probably seen those little things that look like stacked bowls, and those are ceramics. And what they do is they isolate those electrical wires from the pole. So it's very important that we have those there. And again, that's an insulator, and its job is to prevent the flow of electricity. Okay, let's see.
Why don't electricians just wear rubber armor?
All right, so again, that's a insulator. We use insulators all the time. Every time we push electricity through somewhere, we're usually going to have some kind of insulator. So just as an example, when we start doing our first electrical lab, we're going to be using wires that are made out of copper. Copper is the most common wire that you'll see in a house. It's one of the best conductors of electricity, especially considering the cost. But because of the high cost and copper becoming more rare, the prices are going up, and some houses are switching to aluminum. We did have a time, I believe it was the late 70s, where aluminum kind of became the more popular choice, but aluminum tends to corrode more, it doesn't resist bending as well, and it has several other problems that make it not quite as good. It can't carry as much load on the same size wire. So the two metals we're going to talk about are aluminum and copper. Those are what we use for conductors. And then our insulators are going to be wrapped around those wires. It's important that the electricity can't get out and shock someone. So we'll wrap the insulators around those wires. It's good, Samara, I like that. Okay, so insulators. So again, all the wires will be covered in some type of rubber or plastic. I think as things get more expensive, they tend to go away from rubber and move more towards plastics. If you look at the electrical junction boxes, they're all made out of plastic now. They do have metal ones, but those are kind of reserved for commercial buildings nowadays just because of the extra cost to them. So anyways, two most important things you got to know: conductors and insulators. We're going to be using those all the time, and if they're not doing their job correctly, that's why an electrician gets called. So most of our job has to do with fixing conductors and insulators. Okay, very good. Make sure you get a couple of examples of all of these. It's good questions. Mr. Singh asked, why don't electricians wear rubber armor? And they actually do wear some of that stuff. In fact, let me see. I think I have them in the open here. Let me go check real quick. Okay, so in actuality, electricians do wear rubber armor. Okay, so here are some gloves, and they stink because they're some kind of weird rubber. But these gloves we specifically use, and if you were in class, you'd get to see the demonstration of this. We have this fractal burner where we put two probes into wood, and the electricity is so intense, it's high voltage, and it connects through the wood. So if you remember here, wood is a good insulator, right? It doesn't allow electricity to flow through. But what we do is we put some water on the surface of the wood, and then we hit it with this high voltage, and the electricity flows through. Well, because it's high voltage, they recommend using these kind of gloves. And if you look on these gloves, these are rated at 20,000 volts, 20 kV, kilovolts, okay? So 20,000 volts. So these gloves will insulate, I don't know if you can see how thick they are. These gloves will insulate me up to 20,000 volts. So if I touched a 20,000 volt wire and my foot was on the ground, these gloves would supposedly protect me. Now, I don't know if I would trust my life when touching 20,000 volts with these gloves. But anyways, especially because these are from China and sometimes their ratings are a little bit generous. So I don't know if I would trust those, but that's a great question. And rubber is used all of the time by electricians as an insulator. We'll always wear rubber-soled shoes. And, oh, hold on, let me see here. Yeah, you don't have to wear full body armor. You're just going to wear the parts that are going to be hitting the electrical components. So usually it's going to be your hands and your feet are the most important things to protect. But there is a lot of protective equipment, including face shields, safety glasses. We use specialty tools in the electric field that are insulated so that even if a tool touches something that it shouldn't, that the electricity doesn't get through the handle and into your hand. So we do, in essence, use body armor. Let's see. Okay, let's see here. So next one we're into is semiconductors, and these are a very cool medium. It's funny, I meant media, but they're a medium too, because they're right in between conductors and insulators. So we have these things called semiconductors, and I don't remember when they were invented. I want to say like the 20s or 30s, but they really started to get a lot of use in the 50s, because during the 50s, we started to have computers and electronic components. And these semiconductors were key to that development, okay? This invention of the semiconductor is what it actually is a switch. So let me talk about this and I'll tell you how they work real quick. So a semiconductor is neither a good conductor nor a good insulator. And I believe it's like 5 to 6 on the, I don't know if I have it here. I thought I had it in the notes here somewhere, maybe later on. Semiconductor is 5 to 6 on the electron chain, I believe. And then 7 and 8, it becomes more insulator. So semiconductors are right in between insulators and conductors. And the cool part about them is depending on how you charge them, you can make them conduct electricity or block electricity. And this is how a computer works. When we talk about binary with the ones and zeros, that semiconductor is doing that. It's either allowing electricity to flow, that becomes a 1, or it stops the flow of electricity and that becomes a 0. And that's the basis of your binary. And we can mimic that with a light switch. You turn the light switch on, that's a 1. You turn it off, that's a 0. It's either allowing electricity to flow or not. And so the cool things with these semiconductors is you can switch them back and forth. And whereas a switch, I can go up and switch it pretty quick, I don't know, 30, I don't know how many times I could do it a second, maybe like 4 or 5 or 6, I don't know. But with a semiconductor, you could do it thousands or even millions of times a second. And that's what allows our computers to be so fast and so smart. All right, I'm going to turn chat off for a minute because I want you guys paying attention. So we have insulators and conductors, and that's what we're going to be using most of the time, especially in electricity. Those are what you use all the time. Then when we get to electronics, we're going to be using semiconductors too. And remember, a semiconductor is right in between the two. It can be turned from a conductor or an insulator. It could be turned back and forth between the two. And there's two different types that we'll talk about of the transistors later on. But here's some examples: silicon, germanium, and carbon. And remember, we have Silicon Valley here in California with all the tech companies. And the reason it got that name, Silicon Valley, is because it was a computer hub of all of the computer type work: computer programming, computer design and development. I don't know if you guys know, but we have Intel right down the street in Folsom. They've got a sweet facility there. Some of it is ultra high high security, where no one gets in, where they work on their most secret high level chips, where they start stacking all the levels of the memory and all that inside of the Intel chips for their CPUs and for their graphics cards. Very, very cool place. In my last job, I got to work with them quite a bit with some of the high level engineers, and they actually let me in to go see some of the virtual reality things that they were developing and some of the memory chips. Now, I didn't get to go into the top secret areas, but I did get to see the edge of it where some of the security is, and it's pretty cool stuff. But we have really high level computer development right down the street in Folsom because of the big Intel plant. Okay, so just so you know, I always try to buy Intel chips instead of what's the competitor, VFD or AMD. So I always try to buy Intel just because they're local and they try to help out local kids becoming engineers. So just to support them. But a very, very cool company. Again, right down the street. That's a semiconductor. Okay, so when we talk computer chips and we talk computer signaling, that's how a computer is going to work with a semiconductor. Now we're going to shelf semiconductors all the way until we get to the electronics side of this class. But I just wanted to bring it up just so you know. Okay, so we have conductors, insulators, and then right in between them we have the semiconductors. Okay, and again, that's silicon is the most common one, and Silicon Valley. Okay, how much time we got?
Mr. A.
9:37.
Mr. A.
Okay. All right. So this is the part that's probably some of the most important part of the concepts of electricity, okay? So let's go ahead and put the first term down there, and we'll call it voltage, okay? And voltage is going to be pressure. Okay, so make that term, and then I see some hands are up, so I'm going to stop sharing and just answer some questions, okay? Because I want to give a little time for people that need to grade stuff. Okay, let me turn chat back on. Okay, hands up. I see Mason. Go ahead. And then we'll do
Okay,
Suleiman.
so when you're talking about the semiconductors,
Make sure to speak up.
So when you're talking about the semiconductors, is that like CPUs and GPUs?
Yes.
I thought you said something to do with controlling power.
It does. That's what a semiconductor does. It's an electronic switch. So it will allow things to flow or not. It's the basis of all the binary stuff, the ones and zeros of computers. So your computers can do millions and sometimes even billions of computations a second. And the quantum computers are bringing that to a whole new level. So it's a whole brand new thing. But yeah, as of now, we're using computers and they're using those semiconductors. And that's how they're switching back and forth. It's like an electronic switch. Yeah, Suleiman?
Oh, you said Intel makes graphics cards. They don't.
Not the cards, just the chips.
Did you hear me?
So it's different kind of fields.
Don't.
Just the processor for those, just the processing part for the cards.
I don't think they make GPUs, but okay.
They do. They're built. It's one of their big advertisements. It's built right into their Intel chips.
Okay.
Yeah, it's built into their new processors. It's one of their features that they really advertise. So you might be thinking of like separate graphics cards, and I still think some of those actually use the Intel chips too. but they definitely do it for onboard their Intel CPUs. Quantum computers. Someone asked about quantum computers. I don't know much about quantum computers. They're extremely difficult to understand. It takes very high level physics. We'll watch a little video on them later in the year, but they're very, very complicated and I don't understand them. You're gonna need someone smarter than me to explain them to you.
Oh, quantum computers.
Yeah.
So basically, uh, instead of transistors, they use quantum particles because they can be in multiple different states at once.
Yeah,
Because
at the same time.
transistors only output one or yeah, because transistors only output a 1 or a 0, and they still haven't figured out how to like really implement it into like modern day stuff. But
They do have
engineers are
some
working
quantum
on it.
computers that have done some horrendous calculations really quickly. Things they can compute in like a second or two that would take 1,000 years or 10,000 years for a normal computer to compute. But they're very limited in use right now, and they have to be run at absolute zero, which is like minus 400 degrees or something like that. So they have to be run really, really cold. But you guys, I'm sure, will see massive developments over your lifetime with them. Some of the hugest corporations are kind of experimenting with them, but like I said, they are very complicated, and there is some it's weird with the particles, how they'll sync up. Once they get two particles that are in sync, they actually think they can show time travel using that concept. And one of the weird things is particles that are separated by space, like large amounts of space, can instantly communicate, even though it would take light years for a speck of light to travel from one to the other. So it's really complicated stuff. I don't get it. You got to be a high level physics person to kind of get it, but it's really cool stuff. And we will see some big developments, I'm sure, over your lifetime with them. Okay. Any other questions? Yeah, it looks like Suleiman's gotten really into this stuff. Yep, you're exactly right with what you're saying. Yeah, you guys are good in the science. I like this. Got some absolute zero quantum entanglement. Very good. Yeah, absolute zero is cool. There's no such thing as cold in the world. We think of things as cold, but there's only heat in the absence of heat. And absolute zero is when there is zero energy inside of a particle. So it's not moving around at all. So I said it's about minus 400 degrees. I think Riley put the exact numbers there, 460 degrees Fahrenheit. So it's very, very cold. But that's how they run quantum computers right now. You're more into what it could mean for gaming. I guarantee you gaming would be incredible with a quantum computer.
My Xbox only lags like once or twice, like a day or a week.